Imperative versus declarative programming. Imperative programming is about how a program is executed. The exact steps or procedure of the program is listed, and therefore abstraction is minimized. Declarative programming is all about the result. It doesn't matter what procedures or steps the program executed to achieve those results, so long as the result is achieved. Abstraction here is maximized. The best example I've ever heard explain these concepts are how we use CSS in web development. The first example is the declarative way. Here we selected all p tag elements that are direct children of the li tag that also has the class name selected attached to it, and we set that background color to red. Here we don't care about the internals or about how the browser managed to achieve this. We only care about the background color is now indeed red. The imperative way, we actually list the procedures the browser took. So we first get the elements by tag name li. We loop through all of those elements, check to see if the class name is selected on those elements, find the children, loop through the children, find all the children with the p tag, and then set the background color to red. JavaScript's inheritance chain. Each object in JavaScript has an internal link to another object called its prototype. When trying to access a property of an object, the property will not only be sought on the object, but also the prototype of that object, and so on until the match is found or the prototype chain has come to an end. Let's look at an example. Here we have a child object and a parent object. The child object has properties A is 1, B is 2, and we set its prototype to be the parent. That creates the following prototype chain, where this object has this object as its prototype, and so on until you reach null. When you try to access a property A of the child, it will look in the child, and because it exists there, it will return it immediately. However, if we look for child.c property, it will first check in the child, it will not find it there, so it will then check its prototype, and because it exists, return it there. But what if we add functions to this? So here the parent object has a method in it, where it simply returns this .value plus 1. If we call parent.method directly, this refers to the value in the parent. So here it would return this .value, which is 3 plus 1 is 4. However, if we call the child.method, this refers to the child. So although the prototype is the parent and the method exists in that parent, the value that will be used is the one in the child. If the value in the child did not exist, it would then follow the prototype chain to use the value found in parent. So now you know, for example, where array objects get their map function from. The array that you create is the child object, and somewhere along their prototype chain is an array object that has the map function defined on it. SQL versus NoSQL. SQL is a database model that relies on tables, rows, and columns to store data. One of the criticisms of SQL is impedance mismatch, which describes the disconnect between object-oriented programming and models using tables, rows, and columns. The benefit of this mismatch is that it supports data models with many connections, allowing you to join different tables using primary keys. NoSQL is a database model which stores its data in documents, much like JSON, and therefore provides better locality. By locality, we mean that all the information about something is in one place. We do not need to join different tables. That leads to a performance benefit and a better match between objects in programming and documents in databases. The disadvantage, however, is that models with many connections are less well supported because joins do not exist. This often moves the logic of joining documents from the database side to the application side. IP addresses and domain name servers. A domain name is simply a human-readable text that masks the IP address. So when you search up random.com, the browser asks the DNS to find the IP address, which is 181, etc. That IP address is stored under the A record, which stands for address. So random.com is connected to that IP address by an A record. A CNAME record either points to another CNAME record or finally to an A record. So the DNS can respond to CNAME records by following the chain until eventually returning an A record and returning whatever resource is found at that IP address. Server versus client components. A server is a computer in a giant data center that stores your application code and receives requests to send responses. The client usually refers to the browser and makes a request to the server for the application code and then turns it into UI. React lets you render and cache UI components on the server with server components, which has the following benefits. Performance. Moves non-interactive code to the server, which reduces the amount of client-side JavaScript that the browser has to download, parse, and execute. This leads to faster page load speeds. Security. Expose less information to the client. And user experience. UI components are streamed to the client so that parts of the website are visible earlier instead of waiting for the entire website to be rendered. Server components only live within the server environment. The browser never knows about them. Client components, in contrast to what they're called, are pre-rendered on the server and then sent to the client. This allows client JavaScript to run in the browser and make client components interactive. The benefits of client components are that they're interactive, allows you to use React hooks such as use, state, use effects, and event listeners. You can also use browser APIs, have access to browser APIs like local storage.